Manufacturing is everywhere you look. Whether it's your phone, your refrigerator, or your car, somewhere in the world there's a factory that built that for you. But right now, the automation in those factories is expensive and inflexible. It can't keep up with the changing demands of fast product cycles and mass customization. Industrial robots are strong, fast, and precise, but the very things that make them such powerful tools are what make them too dangerous to operate around humans. As a result, they're put in cages and have to be shut down before a human can approach. Power and Force Limited collaborative robots tried to change that way of doing things. But these robots have to be weak and slow, which means they can't do exactly the things we'd like them to do to help people in their work.
Most industrial tasks require big robots like this one. Over 80% of industrial robots are needed for applications that Power and Force Limited robots can't handle. But imagine how these robots could help you if you could work safely with them side by side.
Veo Robotics' first product enables any large industrial robot to operate safely in close proximity to people. The Veo system is the first of its kind. Our intelligent algorithms monitor everything in a work cell and override the robot controls to keep people safe. Veo makes robots aware of the people working near them, so the robots can finally be let out of their cages. To meet the demanding requirements of international functional safety standards, we've designed custom 3D time-of-flight cameras optimized for industrial environments.
Our high-performance computing platform analyzes the camera data and constructs a semantic representation of the work cell, identifying the robot, the workpieces, and the humans. It then projects potential future states of the system. If any part of a person, that's the red point cloud, comes too close to the space the robot could move into, that's the yellow point cloud, we slow down the robot or stop it completely.
We've developed and patented ways of using object classification and tracking in industrial work cells, classifying robots, workpieces, stationary equipment, and areas potentially occupied by people.
We implement speed and separation monitoring, dynamically monitoring the distance between the robot and people in its workspace to ensure that the robot will slow down and come to a complete stop before a human worker could reach it. This means that the muscle in manufacturing operations like this one no longer needs to be provided by people. The robot can provide the muscle, and the human worker can do the parts that require brains and flexibility. By enabling me to work safely with this robot, we can combine the strengths of robots, heavy lifting and pinpoint precision, with the strengths of people, dexterity and judgment, to get the job done as effectively as possible.
There are already millions of industrial robots deployed in factories around the world, and 500,000 new ones are installed every year. Making these robots collaborative and interactive will transform manufacturing, making it more productive, efficient, and flexible. To compete in today's markets, manufacturers need faster product cycles, mass customization, and greater flexibility in their operations. The only way to achieve these goals is by combining robotic power and precision with human dexterity and intelligence. That's the future we're creating at Veo Robotics.